There are these two types of sequences that you want to know. The first type of sequence is called an arithmetic progression. So this is your terms where you can think of this as this is term number 1, term number 2, term number 3 in the sequence. And the property of such a sequence is if you add D, you will get from term 1 to term 2. If you add the same D, it will go from term 2 to term 3. And this goes on. So such a sequence for arithmetic progression, we say that there is a fixed difference. That difference is referring to when you go from term 1 to term 2 and so on. Anything like that, we say is arithmetic progression, or in short, we write as AP. When I mention it later, I will also say it's AP. There are three alphabets that generally describe the terms in an AP. First term, we describe as A. Common difference is D. Last is L, last term of the sequence. But what you need to know is to know this formula. This is the Sn formula. Sn means the sum of n terms. It's given by n over 2a plus L. Okay, I want to emphasize, later we will see this again and again. This n is referring to your number of terms in the sum. If you are summing up n terms, then this will be n. It's an easy formula to apply. So let's apply it to this short example. In this example here, first we recognize that there is a fixed jump throughout. It's always plus 2 when I go from one term to the next. So this is an AP. AP sum. Let's start with number of terms. You can count physically that there will be 7 terms. So it's 7 over 2. A plus L. A is your first term, which is 4. L is that last term, which is your 16. So this we will get 70. Okay, A first term. Just one formula. Okay, we want to remember this form. Second sequence, only two types of sequence. It's called a geometric progression. The difference is for geometric progression, you multiply by a fixed number, which we call it a ratio. So A to AR, you multiply R, and so on. This comes with a fixed, okay, let's write here, fixed ratio. For terms that has got a fixed ratio, it's called geometric, which in short is called a GP. GP, you just need to know two alphabets. One is A, again is first term. R is your ratio. Okay, R stands for ratio. Also one formula. I need to know this Sn formula, sum of n terms. It's given as A 1 minus Rn over 1 minus R. I emphasize one more time, same like the AP, GP and AP, this n is your number of terms in your sum. Sometimes in your schools, they may also present this as follows. If you multiply minus 1 to the top and bottom, there's no difference in the sum, but it allows you to write it in this manner. Now, both are fine. They are the same values. It's just that the difference is the terms are swapped in terms of the plus and minus sign. So let's apply it to this problem. How many terms are there first? For number of terms, I will usually write as a hex to count. You start from power 0 and you end at power 10. This is actually 11 terms. Please count correctly. If you start from 1, it would have been 10 terms. So your A is 2 power 0, which is 1. You are multiplying by a fixed number, so your ratio is 2. So let's apply it to the sum formula. You have A 1 minus Rn over your 1 minus R. Okay, I emphasize again, this power is your number of terms. Note that it does not represent the last power that you have. Okay, this n is always the number of terms, not the last power. Okay, so why are we mentioning this when we were explaining sigma notation and summation? And it comes in these two small examples here. If you see that your term has r, which is your dummy variable is in the power, it will be a GP. So for example here, why is it a GP? If we write out the terms, it will be clear. From my term 1 to term 2, there is a multiplication of q. Q to the power of 1, q to the power of 2, and so on. You're multiplying by q. There's a fixed q throughout, so this is a GP sum. We try to apply the formula for sum of GP. So my first term is q. Okay, A is your first term, it's q. Your ratio is also q. The number of terms coincidentally matches the last power, so it's still n. And we divide by the 1 minus q. Second example, if you are trying to sum up just r, there's nothing else. You sum only r. Okay, I better write you more things here to know that the rest are not AP. I'm not trying to sum r squared, r cubed, or any other types of terms. There's no powers. There's no coefficient, nothing. I only want to sum r. This will be an AP. Okay, why is it an AP? If you write out the terms, it will be clearer. There's a +1 throughout. 1, 2, 3, 4, 5, and so on. So AP formula written for you on the left. You start with n over 2. N is your number of terms. So number of terms here is still n. Number of terms always upper minus lower plus 1. Now for an AP, you didn't need to write out the terms. If it's sum r, the lower limit automatically will be your first term. The upper limit will automatically be the last term. Because I'm only summing up r, I'm going to sub in the lower and upper limit. Okay, so you don't need to write out the terms. I immediately know will be the lower and upper limit, 1 plus n. Okay, what is important is this two formula. I will suggest you memorize it. But after a while, you will be familiar. Okay, these two formulas are both not in the formula list. And when do we apply? You apply when you see r in the dummy variable in the power, or r is the standalone in the sum. Okay, let's go on. Next one. One more page. We will practice a few questions together first. There are these two results that may appear. You will have sum of r squared or sum of r cubed. Both formula not given in the formula list. But if the question requires you to have it, it will be provided. So do not memorize. They are, okay, I write in on the right. They are neither AP nor GP. R squared and R cubed, they are not a familiar sum that we know. Okay, just to prove my point, I just write out a few terms from R squared. If I write in, it will be 1 squared plus 2 squared plus 3 squared. This is 1 plus 4 plus 9. There is no pattern in the sum. You don't get a common difference, neither do you get a common ratio. Okay, so do not treat it as an AP nor a GP. Use whatever formula they give, which I will show you how we can apply. Okay, so let's start with the question below. In the first part today, we deal with slightly easier examples first. We want to learn how to evaluate these numbers. The first thing you should do when you see this kind of sum is, let's go and split up. Okay, like an integration, can we move the sigma notation to both terms? So we open up sum of 6r Continue to copy the limits plus sum of 10. Any coefficient, always we will shift out as well. Sum of 10 is a sum of constant. We will need to count how many terms we have. Let's just count over here first. It's 10 minus 4 plus 1. Always upper minus the lower plus 1. So this gives me 7. Constant 10 times number of terms. So I expect this to be 10 times 7. Second sum, sum of R. What is sum of R? This is an AP. AP, what's the sum formula? I write here. N over 2A plus L. How many terms do we have? I have calculated just now that it's 7 terms. So we go for 7 over 2. A and L based on the limits. I don't need to write out the terms. I know the lower limit is the first, upper limit is the last.